Alright, we're back for more. One thing I want you to understand is we are skipping chapter 7.3 because I think it's really hard to teach proofs when I'm not face-to-face in front of you. So we are actually skipping that section, and we're not going to deal with it. So just kind of pay attention to the fact that we have specifically gone from section 7.2 to 7.4, and that is on purpose. Okay? So 7.4 is all about things called rhombuses, rectangles, and squares. You know what a square is and you know what a rectangle is, but I don't know that many of you know what a rhombus is. A rhombus is just a shape. Oops, that's not the right thing. A rhombus is just a shape where all sides are congruent. That's what it is. So all of these are congruent. Think of it as a square that's been pushed over and tilted. That's basically what it is. It's a square that has been pushed and tilted. Okay? A square, obviously you know what a square is. A square is all congruent sides. Oops. And it also has 90-degree angles. Right? So a square is all congruent sides, just like a rhombus, but all 90-degree angles. Now, something I want you to understand now is that every single square is a rhombus, because by definition, a rhombus means that all the sides are the same, right? And right here, a square has all sides are the same. So a square is a rhombus, okay? So if we continue on here, a rectangle just has all 90-degree angles. So a rectangle has 90-degree angles. You may understand a couple other things about rectangles, like the top and the left and the right. Top, bottom, left, and right are the same, right? Like you might understand that. That's okay too. But again, notice all 90-degree angles, 90-degree angles. So what I want you to kind of think about here is that every single square is a rhombus and every single square is a rectangle. So what I'm going to write here in a second, if I can figure out how to do it, I don't know if I just ruined things, but I hope I didn't ruin things. But anyway, every single square, let's do it like this. If I have a rhombus and I have a rectangle, those are both two different things. Both of those things put together create a square. So that means that every single property of a rectangle is also a property of a square. Every single property of a rhombus is also a property of a square. Okay? The next part is theorems. So with these theorems, these are just kind of things that you have to know. Okay? I would focus more on the pictures than I would on the actual words. But a parallelogram, that's a symbol for a parallelogram, is a rhombus if and only if its diagonals are perpendicular. So that means if you know something is a rhombus, you know those things cross at a 90-degree angle. Okay? So every diagonal in a rhombus crosses at 90 degrees. Okay? So we're going to do the same thing here. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Oops, I should say angles. So that means that a rhombus splits this into two equal angles, and they're going to be congruent to each other. So all four of those angles that you see right there are congruent, and all four of these angles that I'm drawing are congruent. Okay? So just from what you see, we know two things. The angle in the middle is going to be 90 degrees, and all of the angles on the outside are kind of congruent to each other. Okay? Now the next one, a parallelogram is a rectangle if and only if its diagonals are congruent. Which means that all of these in a rectangle are congruent, and that's super nice, right? Because it tells us that all of those things are the same. So those are the three properties of rhombuses and rectangles. Now, one thing to think about, every single one of these properties that you see on the screen right now will apply to a square. Everything. So every single thing that you see will apply to a square. So let's actually go through and mark up these pictures, because this is going to be pretty important. Okay? So a rhombus. First start off, all sides are congruent. Secondly, we know that the sides in a parallelogram bisect each other. That's from yesterday, that's from 7.2. The sides in a parallelogram bisect each other. All of these things are parallelograms, which means they also have the qualities of a parallelogram. Okay? I know that diagonals are perpendicular, and I know that these angles up here are congruent to these angles, and these angles here are congruent to these angles here. That's what I know about a rhombus. Okay? Now what we're going to do is we're going to go right to a rectangle, and we're going to do the same thing. I know these sides are congruent. I know diagonals bisect each other. I know that in a parallelogram, remember, opposite angles are congruent. I know these angles are congruent. And I know that, remember, don't forget the 90 degrees in all the corners. So now what's going to happen is this shape creates a square, and this shape creates a square. So it takes the best qualities of everything. So that means that in a square, all of these sides are congruent to each other, and all of these are congruent to each other. So it takes the best qualities of everything. This in the middle is a 90-degree angle, and every single one of these is congruent. Every one of them. Now, if you remember, all corners of a square are 90 degrees, right? And if every single little piece of the angle is congruent, then that means that every single angle in here is 45 degrees. Squares have some really good properties, and it's really, really nice to have those properties. So when you think about a square, think of a square having all of the best properties of something else. The square has all the best properties of a rectangle, and it has all the best properties of a rhombus. Okay? These pictures are what I would focus on. If you're doing any problems ever with these, I would make sure that you have these pictures out right in front of you, because if you have them out in front of you, then your life is going to be a lot easier. Okay? So let's look here. The way that we label all these, see how it says A, B, C, D? Always label them like this: A, B, C, D. Go in alphabetical order clockwise around the picture. So this is going to be something like this. I'm going to do a couple of these for you so you can see them. A, B, C, D. Now the question is, are they sometimes, always, or never true? So right here it's saying, is angle A congruent to angle C? Is that sometimes, always, or never true? This is always true. In a parallelogram, no matter what happens, that is always true. Okay? The next part says, are those two angles congruent to each other? This is sometimes true when this rhombus is a square. It's only sometimes true. It's not always true, but it's only true when that thing is a square. I'm going to let you do this one on your own. We're going to do a couple rectangle ones. So E, F, G, H. Now it's asking us if EH is perpendicular to HG, which means, is that a 90-degree angle? This is always true. Let's look at another one. Maybe we draw this one. E, F, G, H. And now it wants EG and FH. It wants to know if that thing right there is a right angle because it's perpendicular. And again, this is sometimes true when this thing is a square. Because, right, if something is a square, it's also a rectangle. Okay? If something is a square, then that means it is a rectangle. So let's look at this one. Now, the only one I'm going to do is a square for this one, and I'm going to do this one on the side. So I'm going to put up my picture, M, N, O, P, and it's asking me about M, or NPM, so which means that I'm going to draw this diagonal here, and I'm going to draw this diagonal here, and it's asking me if this angle here, NPM, is congruent to OMN, which is here, and this is always true, because remember, every single one of these little angles on the inside is always 45 degrees, every one of them. Okay? So every one of the angles on the inside of there is 45 degrees, so all of those little angles are the same. Okay? Now the very last thing we're going to do together, you're going to notice on the back of your worksheet you have 3 different pictures. 3 different pictures that you're going to deal with. Okay? Remember the answer key is on there so you can absolutely check things. What I would do is I would give it a shot. See if you can come up with your answer, and if you can come up with your answer, that's awesome. If you can't come up with your answer, that's going to make things a lot more challenging. So if you can't come up with an answer, and you can't figure out how I got the answer from my answer key, then make sure that you send me an email and say, hey, Mr. Shepard, I don't get it. I didn't understand what you were doing here. Okay? So if you get it, great. If you don't get it, then you're going to have to make sure that you ask me. Okay? So, first things first. Angle A is talking about this entire thing right here, which I know is going to be 90 degrees because all 90-degree angles, right? Part B is asking me, and I'm going to do the same thing I did last time. If you need to pause it to see what I did, then pause it. So here, it's asking me specifically to find B. B is right here. It also gives me a hint to use the Pythagorean theorem, which means I'm going to use this entire thing here. So the Pythagorean theorem is going to be 10 squared plus B squared equals 24 squared. Now I'm going to let you do the math on this one. So when you do the math on this and actually figure it out, you should do 10 squared and 24 squared, subtract the 100 from whatever 24 squared is, and then you would end up getting 21.8 for your length. So B is going to be 21.8. Okay? So next what we're going to do is we're going to look at C. So if you need to pause it, pause it. So now let's look at C. So here is C. We need to find C, which is this side, and we know that those two sides are the same because opposite sides are congruent to each other. So that means that C is going to be 10. Now it's pretty important that you understand the reasoning behind all these. It's pretty important that you understand why these are all the same. So if you don't get this, shoot me a message and say, hey Mr. Shepard, I don't understand where you got this thing from. Okay? So D, this one, remember these two angles, or these two sides are the same as each other, so if the entire length of the thing is 24, if I divide it in half, that's 12, because diagonals bisect. So diagonals bisect each other. And finally with E, not finally, but E, remember, in your picture, when we go back to the picture of the rectangle, remember that all of these are actually the same, so again, these are true, because diagonals are congruent. Right? And the very last one, this one's challenging. So this very last one is tough. Okay? So what I'm going to do is I'm going to kind of work through this last problem with you because you might not understand SOHCAHTOA, or you might have a hard time with SOHCAHTOA. Okay? So what I'm going to do is I'm going to go to a new picture here for a second. So if I look at a new picture, I'm going to pick the top half of that rectangle. It looks like this. The one side was 10, this side was 24. This is where the F was pointing, right in here, and this is what we found out was 21.8. That's our B. Now what I'm going to do is I need to find this angle. This is my angle in question, so I'm going to use sine of F. Sine of F means opposite over hypotenuse. The opposite is 10, so it's going to be 10 here, and then 24 is the hypotenuse. Now if you paid attention to what we did in the enrichment stuff a couple weeks ago, then all you know is that you have to switch this and this, here and here, and we have to do the inverse of that. So inverse sine of 10 over 24, and that's going to be equal to something. Now, your calculator will do that for you. On my calculator, I am hitting the second button, and then I'm hitting the sine button, and then I'm putting in 10 divided by 24 and closing my parentheses, and when I do that, I get 24.6. So that tells me that my angle is going to be 24.6. Now that's also on the answer key. That picture that I just drew, that thing that I drew is also on the answer key, so you'll be able to see that there too. But if you don't understand SOHCAHTOA, you have to start asking those questions and saying, hey, I don't get that. Can you please walk me through one of those examples? Okay? So this one was kept to 15 minutes. That's what I hope to do for all of these ones. If you have questions, ask me about it. Try some of these problems on your own. If you don't get it, look at the answer key. If you can't reason your way through it, then talk to me about it. Okay? Alright, we will see you next time.